All right, good morning, afternoon, good evening, wherever you're watching this. Today we are going to learn about relationships of arcs and chords in a circle. Okay. So recall that a chord is a segment with endpoints on a circle. Because its endpoints lie on the circle, any chord divides a circle into two arcs. A diameter divides a circle into two semicircles, and any chord divides a circle into a minor arc and a major arc. So we start off right with theorem 10.3. In the same circle, or in congruent circles, two minor arcs are congruent if, and only if, their corresponding chords are congruent. Okay. If their corresponding chords are congruent, same length, then we can say the chords are the same length. Or excuse me, the arcs are the same length. So we'll apply that. So we have in this diagram, circle P and circle Q are congruent. So that's kind of an important thing. FG and JK are congruent. So we know that right here and right here are congruent. And the measure of JK, the arc JK, is 80 degrees. We need to find the measure of arc FG. So we need to find that one. So, using theorem 10.3, knowing that our circles are congruent and JK is congruent to FG, we can say that the measure of FG, arc FG, is 80 degrees because JK is 80 degrees. Ooh, here we got a tricky one. We're told here that measure of AB is 110. We know that AB and BC are both 9. So using theorem 10.3, we have two chords that are congruent on the same circle. We need to find the measure of BC. So we need to find this measurement. While applying theorem 10.3 again, we know that since AB equals 110 degrees, arc AB, excuse me, then we know that arc BC has to equal 110 as well. Has to equal 110 as well. Okay. For the second part here, using the same idea, we know that AB is congruent to BC, so they're both 9. This time we're told AC is equal to 150. We need to find the measure of AB. Well, what we have to do, we have to remember 360 degrees in a circle, not equal. We know that our minor arc is 150 degrees, so that gives us 210 degrees. But we got to think that's covering major arc A, B, C. Ooh, I don't want a line there. Is 210. And because we know that AB is equal to BC, all we have to do is take 210 divided by 2 and get 105 degrees. So we now know that the arc AB is equal to 105 degrees. All right, so here we go. What we have is if XY is congruent to YZ, then the point Y and any line, segment, or ray that contains Y bisects XYZ. Interesting fact. We've got a couple theorems here. If one chord is perpendicular bisector of another chord, then the first chord is a diameter. So what that would mean is I got my circle, got my first chord, and I got my second chord. That would have to be a 90, and that would have to equal that. We got theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Again, same idea as up here, just applying it a different way. So we have as 3 bushes are arranged in a garden as shown. Where should you place a sprinkler so that it is the same distance from each bush? Doesn't look like circles. I don't see any circles, but we're going to apply the last theorems. What we're going to do, we're going to just draw a line between our 3 bushes. So let me try making it a little bit bigger. I'll get my line tool. So I got a line going between bush 1 and 2 and 2 and 3. No, it's kind of hard. I'm going to change the colors for you. So we got our 2 lines. It's like, I still don't see a circle. But what we're going to do, we're just going to apply that perpendicular bisector. So we're going to draw a 3rd line and a 4th line. This time we'll try making those a little bit different color. Make them, a blue should show up on here. Draw my perpendicular bisector. And that will go both ways. Remember, for it to be a perpendicular bisector, right angle. And I've got to shift that a little bit. Try getting that right in the middle so that each chunk is the same distance. And we're going to do the same thing to the other side. Use blue again. So I'll draw my perpendicular bisector. Oh, not what I wanted. Change that color and make it a little bit easier to see. And again, perpendicular bisectors should be 90. And they should be the same distance. They look pretty close on my quick measurement with my hands here. You can't see. So now we know where to place our circle. We're going to put that right where they intersect. That's where we're going to put our sprinkler. That's going to equally hit all 3 bushes. You don't have homework like this. This is just kind of showing you what we can do with the idea of circles that we don't hardly see. So what we have in this diagram of circle E, we need to find the length of AC and tell what theorem we used. So we're looking here. We know in circle E, AF is 7. And we know that BD is a perpendicular bisector. So that means that FC also has to equal 7. So AC is going to equal 14. And that's by theorem 10.5. By theorem 10.5. All right, here we go. Another problem. Ooh. We know to find the measure of the indicated arc in the diagram. Okay, so we know that BD, diameter, perpendicular bisector. So we know those 2 parts are equal. So we're able to set our arcs equal to each other. So we know that 9x equals 80 minus x. All we have to do is solve for x. Add x to both sides, get rid of that minus x. Divide by 10, x equals 8. But that hasn't answered our question yet because we're trying to find CD. So we're going to have to go all the way back take 9 times 8 and get 72 degrees. On your homework tonight, they're just going to have you find x. But got to be careful because they might throw this in on a quiz or something. So we know that 9x is 72 degrees in this problem. Now they want us to find CE. Well, CE is equal to CD plus DE. And we know that CD and DE are the same measurement because of the theorem, 10.3, I believe it was. So we're able to go 72 degrees plus 72 degrees, which is 144 degrees. Theorem 10.6. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant away from the center. Okay, I'll do a couple properties of this here. And you do have a couple of these on your homework tonight. So in this diagram of circle C, QR is ST, or QR equals ST, which is 16. So we know that the chords are the same length. We just got to prove that they are equidistant away from the center of the circle. And we're told that CU equals 2x, CV 5x minus 9. So we've got to set those equal to each other. So we have 2x equals 5x minus 9. Subtract 5x. Negative 3x equals negative 9. Divide by negative 3. X equals 3. But hold on a second. We're told find CU. So we've got to plug back in. So we know that 2 times 3 equals 6. So CU equals 6. Oops, got through this a little bit faster than I thought. Okay, main thing today, remember, if we have a perpendicular bisector, that's going to bisect chords into two equal parts. If we have two chords that are the same measurement, they're equidistant away from the center. And vice versa, if they're equidistant away from the center, they're going to be the same measurement. Okay? So let's give you your homework now. On your homework tonight, you have page 667, number 3 through 12. Number 3 through 5, you need to apply what we know. So think of the theorems. And number 6 through 11, all you're going to do here is find the value of x. But I want to give you 3. And I tell you what, don't do 12, do 11. Give you guys a little break since you're doing this off a video. Okay, that is your video for today. Hope you have a good day. We'll see you guys all on Thursday.